Hello, everyone. This is SEC1337, week 6. Today is, this marker sucks. Today is May 19th, and it's a fun week because it's about cloud security. My head's always in the cloud, so this is very relevant. So it helps to talk about what the hell is the cloud. Yeah, you get a lot. It's another one of those buzzwords like machine learning, big data, AI. The reality is, though, that the cloud is just something outside of the four walls of business. So, you've got these major cloud providers. You've probably heard of them. You've got the big one, which is Amazon Web Services. This has been around since 2007. A lot of companies have been able to do their thing because of AWS. And then you've got Google with their Google Cloud Platform and GCP, you probably heard. And then the one that always throws people off, Microsoft Azure. I call it Azure, not Azure. But this right now is like the 1, 2, 3 as far as size and number of customers. And what they essentially do is they have their own data centers and they provide you the ability to use infrastructure as a service. So you can run entire virtual machines. You can access, things called Lambdas, which are serverless compute. You can run databases. You can do your identity as a management, your identity and access management. You can do encryption, all in the cloud. The benefits are if you're a company that's growing, your infrastructure will scale automatically with you. So you don't have to worry about running your own data center, running your own infrastructure. It grows as you grow, which is nice. It's also reliable. They have to follow the 5 nines, 99.999% uptime. And they're generally pretty consistent. There have been outages with these platforms, but it's normally specific to a particular region. So like if the East Coast goes soft, they can fail over to the West Coast of the US, or they can fail over to New Zealand, Australia. They're globally distributed, kind of like the network of princesses I'm building. Anyway, and then the security, there is a certain level of security that has to be provided, not only by compliance standards, like PCI, NIST 800-171, and CIS, but also just by, legal and privacy sort of laws, mostly in the EU, because the US doesn't really care about privacy, but GDPR and stuff kind of requires that they have certain levels of security. But there are cons. It gets expensive. AWS can be a lot to run, because you're paying for the infrastructure, the security, the services, the support, all of those things. You also don't have access to hardware, so you have to get creative around security, and we're going to talk about that. You have to use software-based security models instead of hardware. You can't just put cages in. You can't rely on full disk encryption. With a FIPS module, like a hardware security module, you have to actually use software-based methods. And then you also are kind of putting your trust in them. So they have all your data. You have to hope that they're going to run. You're going to have to hope that they stay around. You would hope that Amazon, Google, and Microsoft remain in the business, but they could go under. There could be a big breach. There's also this other issue along with this of vendor lock-in. So when you're on one of these clouds, it's really hard to get off of them. You have to get creative and write your own APIs. I've done a couple migrations before from AWS to GCP and Azure to AWS. It's not easy. There's certain tools and companies that provide it, but it's not an easy task. So cool. Let's talk about next mode, securing the cloud. Wait. Yes. Oh yeah, securing the cloud. Are you going to control the slide or am I? Oh yeah, you're good. So with the cloud, there's this whole thing called the shared responsibility model, and it kind of looks like a triangle or like a grid. It's basically like this, and it's like if you are relying on AWS manages infra, the platform, the software. And then you as a customer, you're only really responsible for the data and the sort of software-based controls. And so they have to provide this level of security and service. And so you have to hope that they're providing security, but you can't just necessarily depend on it. So, we can manage this stuff through software and through code using this thing called infrastructure as code, IAC. And this is essentially, if you've ever heard of Terraform by HashiCorp, we talked about this last week. Terraform is a way to programmatically declare infrastructure. So if you've got like 20 AWS, what are called EC2 elastic compute instances, you can define them all using like this simple language called, well, it's a HashiCorp common language, but it looks like YAML, yet another markup language. So you write this out and you say like, I want, resource, this number of instances, like times 10. And so it creates all these instances all at once, and you can also have people review it. So you do your little plan. Your plan then has to be, or you do your plan and your apply, and then people will actually review this stuff in your source code and make sure that you're meeting like certain levels of security and consistency and reliability. This also allows us to create guardrails. So you can say basically that with your code, you can say, okay, if we're going to create a bucket, which is for storage, like an S3, this has to have encryption, right? And we need to have the bucket be encrypted. We also need to have the transit to other parts, like to the SQS, which is the queue, or the simple mail service. We need to have encryption using this thing called key management service. We also don't want to have it be publicly accessible, because this is what Amazon kind of did by default in 2013 until they started fixing it. Every bucket was world writable and world accessible. Even if you had another Amazon account, it wasn't even AWS. And so if you could punch in the ID of that account, you could literally read the data on the bucket by default, which was no good. And this is why a lot of breaches ended up happening. So Terraform infrastructure as code allows us to define the guardrails and even set like standards. Like if this isn't going to meet our requirements, it can completely fail the build, And so you can use stuff like AWS config. You can use stuff like Wiz, which creates the guardrails. There's also Orca, all these different services to create certain standards. And then this also allows us, there's a really great service called asecure.cloud, because you can use your own top level domains now. This provides like a variety of different templates for Terraform, for this thing called CloudFormation, which is built into AWS. And it allows you to like, okay, I want to deploy an entire logging infrastructure, and I'm going to do that through Terraform. I'm going to like configure CloudTrail, GuardDuty. I'm going to configure CloudWatch, which is essentially like it's alerting and monitoring, Security Hub, all these cool little things. So yeah. Now, securing the network in the cloud is a bit different, all right? So normally, if you go back to the network security class from week 4, I talked about a lot of different controls you have. They're still relevant here, but we're not able to like manage the physical infrastructure. We can't tap into ports. We can't create like a span port. A span port contains like a replica of all the VLANs. That's what allows you to get insight into the traffic. We also can't just arbitrarily monitor, logs and things, because it's not of the same value. So when you look at like the cloud in AWS, for example, they have this thing called like a VPC, which is a virtual private cloud, and all your stuff kind of communicates, like your instances communicate to your database, RDS and your Lambda, but they're doing a lot of this stuff over APIs. We're not necessarily interested in what's happening with the routing and switching, because we're not focused on layer 2. We're only up to layer 4. So when AWS provides you security, they provide you this thing called a security group. In Azure, it's called a network security group. It's all pretty much the same. And this allows you to define at layer 4, like the source IPs and the ports. That's it. So it's pretty rudimentary. And you can also define by groups too. So if you only want to have like basic database group, can talk outbound to this web group, you can do that. But it's not layer 7. It's only looking at ports and source IPs. So we need to rely on things that are more directly related to APIs, but also the hosts. So like for our VMs, which are called EC2 instances, like I mentioned, we can deploy like a host-based firewall. And so you have a lot of stuff built into Linux. Like Windows, you've got you've got Windows Defender if you're running Windows servers. On Linux, there's this great thing called CrowdSec, which is essentially allows you to run on the agent and say, like, block these IPs, allow these IPs. You define everything on the host. And again, you can use Terraform to define this en masse so that you don't have to configure on every single host. Like when you deploy it, you say put CrowdSec on, put IP ban, turn on Wazoo, which Wazoo is actually a host-based intrusion detection system. So if you remember from chapter 4, host intrusion, IDS and IPS, this is going to tell you that something's amiss. Something got through your firewall, something got into your network segment, and the host-based intrusion is going to look at two different things as a refresher. Signatures, like, okay, somebody has tried to run like Mimikatz to dump all the passwords. Not good. Or somebody just, you're seeing behavior where this user never runs PowerShell, and then all of a sudden they're running PowerShell to pull down like an executable to run on Windows. So that's the anomaly-based signature, heuristic, and anomaly. So Wazoo actually does both of these. And this is on the host level. So you deploy it on your hosts. And then on the network level, if you will, you're looking more at like the application programming interface. So whenever you're in AWS, any sort of action that happens, it hits like an API. It doesn't actually just like, there is traffic that happens through like what's called the VPC flow log, but it's noisy. It's not particularly useful. Instead, there's a service called CloudTrail. And CloudTrail essentially logs all API requests across all services in AWS. In GCP, you got Stackdriver, and Azure, you've got Sentinel, but CloudTrail basically says, okay, this EC2 instance made this request, this Kubernetes cluster, move this pod. We're going to make every API call gets logged. And then CloudTrail is kind of the raw logs that then can send to CloudWatch, for example. CloudWatch will allow you to create alerts. So if EC2 is doing funky, wonky ass shit, you have it alerts, like send you a PagerDuty message or a Slack message or any number of different things. And then you have this larger sort of, this is the closest thing to a lean seam is called GuardDuty. And GuardDuty tries to do analytics based off CloudTrail. It says like, oh, there's this IP from Russia that keeps hammering all your web servers and it's filling up CloudTrail. We're going to flag an alert, right? And it allows you to then investigate. And or you've got people that are trying to read your buckets, or they're moving data from this S3 bucket to another S3 bucket, or they're running, next week we'll talk about application security. They're running server-side request forgery because they're hitting what's called the metadata API, which is on EC2 instances. All this stuff is anomalous. GuardDuty alerts you and allows you to take action, but then you can send all this shit up to an actual SIM, and there's some really good ones out there, and we'll talk about that in week 14 with security operations. But one of the best is Panther. There's also Wazoo is actually a SIM as well. I love Wazoo because it's free and open source and you can deploy it yourself. Plus it has all these different agents for Kubernetes, for EC2, for S3. I would say start out with Wazoo if you're just looking to run something for free. And it allows you to look at API calls. So that's really important in the cloud security world. But again, we can't traditionally look at network security monitoring like with Security Onion because we can't tap all the ports. We can't look up the VLANs. They don't even mean anything to us because there's so much traffic moving. AWS manages the networks. They just give us this little cloud that we can do basic routing over layer 4, but it's not particularly useful because we're not able to look at all our VLANs, because it's software defined network security. Hit it. And then, so similarly to the network security, there's a lot of interesting techniques in the cryptography world. So, we can still use encryption, but we don't physically manage the keys with hardware security modules. So we can have sort of software-based keys that we can escrow in like, a secrets management system, for example. So like with Windows, because Mac doesn't really provide any like enterprise level systems. I mean, they do, but not really. But Windows and Linux, we can have full disk encryption, FDE, and we do this on Windows with BitLocker. And then the actual keys, we want to escrow and something we control. So you could have them be offline, or since I love going to the Church of HashiCorp, there's this thing called HashiCorp Vault that you can run or in the cloud, and it's a robust secrets management system. So we can store our keys in here, and we actually have it programmatically decrypt the disk. So like when a new machine's getting bootstrapped or when it's booting, we can actually have HashiCorp through the API decrypt it, one-time decrypt, and then it goes back to its thing. You can also enforce this thing called access control lists. So you can say, okay, only certain machines have access to this particular key escrow. Only this server can run this SSH command. It's really cool. Highly recommend looking into HashiCorp Vault. It's a beast of a product, but it's really awesome. There's also AWS Secrets Manager, which we could use for the same thing, but it's not nearly as robust. But it is built in AWS. That's one of the things you'll have to contend with is, do you want best in class, or do you want the ease of use of having everything provided by one cloud provider? Personally, I like best in class, but a lot of people just kind of stick with what AWS has because it's easier to manage under one umbrella. So I don't think there's a right or wrong answer. It depends on your team and if you have the expertise to manage this stuff. And and if you have multiple clouds, obviously you want HashiCorp Vault because Secrets Manager is not going to cut it for GCP and Azure. And most companies now are multi-cloud because of different requirements, different customers, or early on they had people spinning up stuff, special snowflakes. Snowflakes, by the way, are like are resources outside of the normal paradigm of what you're managing. So if you have everything managed under Terraform, but Bobby Joe, whatever, he wants to manage his own EC2 instance, you don't really want to allow it. It's called a security exception because the moment he does that, we don't have the same control over the security, the configuration. It's just going to be sitting out here, and next thing you know, it gets hacked and it's used to pivot in. So avoid the snowflakes where you can. There are sometimes legitimate excuses, but not always the case. Now, similarly with full disk encryption, if you have data you want to dispose of, normally you'd be able to, if you had access to the hard disks, you could write over. You could do what's called a DoD wipe with like ones and zeros using like Hiren's boot disk or active kill disk. You could write over this like 7 times. You kill the disk. We don't have that privilege. So what we do is we essentially have to ransomware ourselves. I mean, not totally, but you essentially encrypt. You use PGP and you crypto shred. So you write over the data with encrypted, with ciphertext, and then you make it and you throw the key out. You make it unreadable. That way nobody can recover it. No law enforcement, not even you. That's one way we dispose of data. And then, the key management system in AWS is also really helpful for managing keys. It's similar to Secrets Manager, but not entirely. But every service that requires encryption needs, like in AWS, relies on key management. It's a symmetric key. So like S3 uses it, RDS, your EC2 instances, and then you can store, for example, the private key in Secrets Manager, but the public key is on the actual instance and device itself. And I already mentioned HashiCorp, which is awesome. And you should be using encryption for data at rest and data in transit, So whenever they talk about we encrypt, make sure that they're encrypting on the disk and as they're encrypting in the transport level. Both are important because if there's plain text at any point, you can decrypt and reveal the underlying ciphertext. And then there's this whole thing, which I kind of alluded to earlier, called CSPM, Cloud Security Posture Management. This essentially has to do with the guardrails, but so AWS Config, Wiz, Orca, they will look at your config and say, okay, here's what you say is acceptable in Terraform. If you've got an S3 bucket that's open to the world, boom, we can actually just deny it. We can kill the bucket. Or if there's no encryption being used for your queue, we can kill the queue. We can literally destroy the resource. Or we can enforce they use a key. It's a way to keep the guardrails, even just be alerted. And similar to the intrusion detection versus prevention, we detect first, then we prevent. So we don't want to immediately just kill everything because you could completely ground your infrastructure to a halt. But you detect that it's happening with a misconfiguration, and then you have it intervene. And that's essentially how you manage it. So so the cloud, again, it's great. Most companies have moved to it. A lot of companies that are old have a hybrid model. They have some stuff on-prem, some stuff in the cloud. Ultimately, if you don't have a team of people to manage infrastructure, cloud's the way to go. But don't fall into the illusion that you're just secure because you're in the cloud. You still have to take a lot of steps to secure it using software-defined methods for networking, cryptography, infrastructure, and so on. So that's what there is to say about CloudSec. Any questions, y'all? Yeah. CloudSec. Yeah, I know this is your world. Zach.
Yeah. So, with the different systems in place, and you were saying how it was really difficult to kind of build a crosswalk between, like, let's say Azure and Amazon Web Services, right?
Yeah.
And you're saying that these third-party companies that basically exist just to kind of make the crosswalk like possible or easy. Are those like big vulnerability? Like I would assume that's like a big point of vulnerability.
It can be. It's like the hardest part is just like securely connecting the clouds, right? So actually one of the like network, what's called a service mesh, is HashiCorp Console.
Okay.
And Console is neat because it's a layer 7 networking technology, and so it uses certificates, what's called mutual TLS.
Okay, yeah.
And so this is agnostic of the cloud, so you can do this really, really well. But if you're, this allows you to connect clouds securely, but it's really hard to administer too, because you're literally having to put different VPC endpoints. You're like, but this is how a lot of offices are. If you think about maybe this cloud is like, you can look at this as US East is AWS, and then US West is GCP. So you kind of have to abstract it and break it down to modules, because within each cloud you're going to have different levels of networking too. But you can also extend Console to that, or Console. There's also Istio is another tool that's like layer 7, which is like Java, and it's really complicated. There's a lot of like different networking at layer 7. But if you were to try to manage this, like I've seen companies try to do this from layer 4, or actually like deploy like firewalls or software-defined networking, it gets really, really complicated. You really want a service mesh, and that's honestly the only way, and I'll talk about this next week, to connect different applications, So if you look at what they call microservices, the whole idea with that is like, okay, you've got this messaging stack, right? And if you pull this out as a module, it's not going to collapse the entire like database stack. It's going to like mess up messaging, but there's still going to allow to be processing to happen. But you connect these services using like a console, like a layer 7, instead of having to know, oh, this messaging queue is going out this IP. Like it's infinitely complex, So this is like the monolith, which is the waterfall approach, versus the microservices, and that's the modular approach. Even just like if you think of something simple like building a PC, if you've seen the new modular power supplies, like you can plug in different size volt, like you can take
specific components.
Exactly. So that way the whole thing doesn't collapse if it fails. So like modularization is the way to go.
It seems like that's the way of the future for everything.
Yeah,
like
of course.
You're looking at the military and how they got so obsessed with one model that could be modular, like the F-35.
Yeah.
It's like they replaced everything that flies with F-35, different variants of it.
Exactly, yeah, and they love it, but it's just like, there is a single pane of glass, but then there's a single pane of failure too.
Yeah, that's what I was saying. If the enemy finds the weakness of the F-35, then it can be applied across the board, which is kind of sketchy.
And this also plays into the kind of mindset of like mitigating the blast radius. Like if you take over messaging, you're not going to just take over the database, because this is isolated. You're not going to just take over the web server. So all this fits into the kind of model of security modularization as well, and like zero trust and all that. Pretty decent.
So I think that's something we will be able to help other companies implement it.
Yes, because oh my God, so many like
I know.
Marriott's a big ass waterfall. Like this is part of why there's all this shit going on, with like their code where it's like, there's been 100. They say there's been like 78,000 hands that have touched their code base since they've been around. Can you imagine that?
78 is more than others.
I'm like 524. SEC1337 or something. Like, I don't know, since 1927. But like, you can imagine all the
That's insane.
chefs in the kitchen or whatever. It's
And
wild.
then I find that with these services, enterprise services, a lot of the times how companies are integrating them is through one API verified user or something that is shared across sometimes multiple different things, and it's like more than one person has access to this login, and it's like, holy shit.
Yeah, you can see all the bad behavior and just like
I can just see the mistakes that even like true accidents that happen.
Yeah, of course.
That just like break everything, or how which direction data gets updated. Where's the source of truth, right?
Right, you don't know. And then think about have you ever seen this where there's one user account, like an employee account tied to all this, and then they leave and everything breaks? Because it's like, that just got deactivated. You have to let it force point.
The funny thing is, a lot of the shit that is running is under my name, so they can't freeze my account. They have to let it keep going.
Right, and until they just like,
And we haven't like previous people, like my previous boss, a lot of stuff was built under his name, and we left his account running because it's just too much. It takes so many man hours to create a new person and transition everything over to that person.
It's crazy,
like more complicated than you think.
Yeah, absolutely. Yeah, there's a lot. And just, I mean, you can see, like, when it's built into the processes, it's just the same reason why the airlines can't change easily.
Yeah, that's why they crashed that year. Oh my God, that was Southwest. That was embarrassing.
Oh yeah, just all the mainframes and shit from the 70s. Like, they're trying to phase it out. And, like, you have companies like TravelPerk and Spot Nano that are building on top of it, but they're not able to get to the underlying code. For that reason.
It's still all running on the old stuff. And same with like internet banks. It's like internet banks have all these fancy new things, but at the end of the day, they're still tied to brick and mortar.
All the neobanks are just like front ends, for the shit behind the scenes. But, boutique. Cool. All right, so that was fun. All right. Well, these classes end up being 30 minutes, but like I said, with all the rabbit holes you go down, it's going to take a lot more time. So next week, we got application security. This is going to be a fun one because I'm going to teach you about how to do bug bounty and get all the free shit, which is what I do all the time. So it's been real. Till next time. Peace.